Okay, so this is our class for Thursday, and we are going to be doing a few things today. One of which is we're going to go through the 5.4 homework page I handed out the other day. So let me see, view the blog. So here's the plan for today. This is attempt 2. We had a computer crash a minute ago. We started this video a minute ago, and we're starting it again. So we're going to finish the examples in the first part. Oh, sorry, this is Thursday. We're going to go over the second page. Actually, we'll go over both pages of this worksheet, and then we're going to do a little lesson on z-scores. So that's the plan for today. So what I'm going to do first of all is go and open the answer key to this. Now, if you go to yesterday's video, I went through in some detail how to do this question on the TI calculator. So I'm going to try to shortcut this a little bit and do it with the with maybe the frequency distributor. Okay, so I'm going to see if I can copy all of these. So Control C, and then I'm going to go to maybe this would be very hard to do in your phone, but this is just me doing a shortcut. You can just type all those numbers into your phone, but I'm just trying to save time here. So I'm going to open a document and paste them. And oh yeah, so there we go. So these are now, it just kind of accepted all of that as just plain data. So I'm going to try to maybe put some commas into it. So it was 91, comma, 129, comma, 95, comma, 96, comma, 96, comma, 90, comma, 101, comma, 87, comma, 100, comma, 90, comma, 96, 78, 105, 99, 81, 106, oops, missed the comma, 101, 122, 91, 102, 89, 125, 162, 155, 89, 89, 180, is that right? Is 180 one of my pieces of data? That seems big. Oh yeah, that is the one big piece of data. What movie would that be? Remember, this data represents of somebody's collection of movies, and they've decided to organize them by how long in minutes the movies run, which is a bizarre idea, but okay. Ours is not to judge. Ours is to just do the statistics. I actually don't like that this number has been split up, but oh well. We'll see if it works. Okay, so there we go. We've got all the numbers now in data, just separated with commas. So now I'll go back to the blog, and okay, so which one do I pick? If I'm not using a TI calculator, what calculator will give me a histogram or a frequency table? I guess I can just go histogram generator. I'll just use this one, right? So histogram generator, right? Because the first thing I gotta do is make a histogram. Okay, so maybe actually I will do this. Maybe I'll actually open the other one. Because I gotta make a frequency table before I can use that one. So I'll go to the frequency table calculator first. There we go, frequency table. So I'm gonna enter my data, and so let's see. We're going to enter, oh, wait a minute. Does this make me a frequency table? No, it doesn't, does it? It does? Yeah. Okay, so how do I, okay, so let's enter the data. Maybe I'm using the wrong app here. Maybe I should go to Calculator Soup. Well, let's try this one. Okay, so I'm going to go Control C, and then go back to that thing and that app, and where are you, app? There you are, and put it in there. So Control V. There we go. And okay, how do I enter it as a frequency table? How do I enter group data? So there we go. Frequency. So there we go. So calculate. And okay, so frequency 1. So there we go. So I have 73. So now from here, I can very easily make a frequency table myself. It doesn't really make it for me. It does the stats that I want. It does give me my mean and my standard deviation. Although actually, no, it's not. It's still kind of grouping these things together. Oh, because it's doing it as a cumulative frequency, that's why. So, oh yeah, here's the problem. These numbers here, it all just kind of glommed them together. So 180, after the 180, something goofed up. After the 180, where is that in the list? 180 is, which row is it in the list? So after the 180, I have this weird number. I must have lost some, there it is. 162, comma, 155, there we go. And then 162 and 155, are those pieces of data? Yes, there. There we go. That should work now. Recalculate. And let's see, did 135 work? There's 135, and then the comma for it ended up on the next line, and then 100 happened 4 times. Yeah, okay, we're good now. And this gives me the mean that I had last time, which is 104.5, and the standard deviation, which is 22.3, and those are the same numbers I got last time. Now, how do I make a histogram out of this? I actually do have to maybe now take a piece of paper and group together. So, or just open up the other app. I'll just open up the other app. Okay, so the other, oh, wait, where did it go? Why did it leave me? Okay, I don't know why it did that. Well, that's unfortunate. I'm going to have to do that again now. Okay, fine. It just closed the page on me, and I don't think I asked it to close the page. All right, fine. We'll just do it again. Sorry, this is going to take a little longer than I thought. Okay, so my frequency table calculator, open that in a new tab. Give it its own tab. Histogram Generator, give it its own tab. Okay, so this one here, I'll just enter that, Control V again. There we go. Fix the one problem I have. There we go. And then calculate. Okay, so this doesn't really make me a frequency table, but it's easy to make one now. So now I want 70s, 80s, 90s, 100s, so 70s, 80s, 90s, 100s, 110s, 120s, 130s, 140s, 150s, 160s, 170s, and 180s. That's 12 bins. So my histogram has 12 classes. My lowest data point is 70. My class width is 10. Okay? Anybody not sure how I'm doing this? Right? Look at the frequency. 70s, 80s, so I start at 70. I'm counting by tens. I'm going 70s, 80s, 90s, 100s, 100s, 10s, 100s, 20s, 30s, 40s, 50s, 60s, 70s, 80s. So that's 12 unless I've counted wrong. And then prepare the frequency table, and now I just count and make kind of a tally chart here. How many are in the 70s? 2. So I put a 2 in there. How many are in the 80s? 1, 2, 3, 4, 5, 6, 10. 10 go in here. How many are in the 90s? You could do this by hand, but this is, I think, faster. 2, 4, 6, 7, 10, 11, 15. 15 goes in the 90s. Right? How many in the hundreds before you get to 110? 4, 6, 8, 9, 10, 11. So 11 goes here. How many in the 110s? 1. I guess 110 would count. So 1, 2 are in the 110s. 2 in the 110s. 2 in the 110s. How many in the 120s? 1, 2, 3, 4. How many in the 130s? 1. And this is that part of the histogram that we already saw, where it kind of, there's those little bumps on the right-hand side. How many in the 140s? 1. How many in the 150s? 2. It's possible I've lost some data. You get the idea, though. How many in the 160s? 1. And then there was nobody in the 170s. And then there's a 180. And I think it's just one of them, though, right? And there it is. That should give me, oh, what did I miss? Oh, I have to actually say 0. Gotcha. 0. Graph it. And that's the same weird histogram that we got TI and on Desmos when I hit histogram for set A, where I typed all this in, and I set the data bin to be 10, and I set the frequency to be left. And again, I'd have to stretch these out, which again is easy to do. You can just set the y-axis to -4 and then stretch it up. I don't think you need to go as high as maybe 20. And there we go. This graph and this graph and this graph are all the same thing. Okay, so I don't really care which technology you use when you're doing these assignments, but there we go. And all three of these apps find standard deviation. So let's do the algebra way now. So the standard deviation and the mean. Let's do it with Desmos first. How do I find mean? I can either just type in the word mean, or I can go to my list of functions, stats, mean, and then I want the mean for data A, 104.5. When I'm on the apps, this one here doesn't find me a mean, so I have to go back to the actual calculator, and there it is. There's my mean, 104.5. Remember, mean, the symbol is mu. And standard deviation on this one, remember, I want the regular standard deviation, not the sample. It doesn't say it's a sample of his movies. It doesn't say this is some of this guy's movies. It's a population. So 22.3 is standard deviation. On the TI calculator, where's the TI calculator answer sheet? There we go. Standard deviation is right here. And I can make that bigger so you can see it. Right, from one var statistics, standard deviation is 22.3. And for the other thing we were using, the frequency calculator, oh, sorry, that's it. That's what Desmos was the other thing we were using. And for Desmos, standard deviation, remember on Desmos there's 2 standard deviations, and again, this is a population, so use the P1. And there we go, 22.3. So now, once you have the mean and the standard deviation, what do you do with it? Well, you have to figure out, is 68% of the data one standard deviation to the left and right of this? So here's the question that I had from somebody in class. How do you do the algebra part? Okay, so here's how we do it. Let me get a page here to work on. Okay, so let me just go to a scrap page. There we go. Okay, so okay, so the question was, the microphone probably didn't pick it up. If you're doing the intervals, like back on your histogram generator, where does an 80 go? Well, take a look at the way I've set up the intervals. 70 has an equal on it, but 80 doesn't. Now, how did I set it up that way? Well, I set it up that way by starting at 70, going with our class width of 10, but saying that the boundary is the lower class limit. So in other words, 70 counts with the 70s. 80 counts with the 80s. On Desmos, you tell it to do that by, when you're doing your histogram, aligning left. And on the TI calculator, you do that by setting your window. Can you see that window thing? I'll make it bigger. Setting your window and counting in a scale. The scale is 1. Actually, it does it. You know what? I've just realized the TI does this. The TI does this automatically. Yeah, the TI, you don't have to worry about it. It does it automatically.
So if it's like an 80, it would go from like 80 to 90.
Yes, that is correct. Okay, so there's the 3 different technologies, and they all basically work the same. So now let's do the algebra way. So the algebra way, what did we find out algebraically? We found out that the mean is 104.5, and the standard deviation is 22.3. So we expect 68% of the data to be between these 2 numbers. That's for number 1. Okay? So minus those and plus those. So when you minus them, you get 82.2, and when you plus them, you get 126.8. So now, how much of the data is that? Well, let's see. Go back to your scores and put them in order. On the TI, that's just the sort function. Okay, on this thing, on the histogram generator, you can just say, okay, how many are in the, okay, so you have to be between 83 and 126. So actually this one doesn't help. You got to go back to the regular, this one. So how many of them are between 82.2? So you can't count 82, so you have to start at 83. So how many are 83 to 126? Can't count 127 because you don't quite get there. So how many are 83 to 126? So add up how many there are from here to here. And if you add up all these numbers, I won't bother going through that because I've already done this once. When you go through that, you find out that that's 40 scores out of 50. There's 50 scores, 40 of them are between these numbers. And that's 80%. Too big to be 68%. So that's why we reject this and say it's not normal distribution. Okay, let's look at the second question now. The second question gives me frequency tables, which makes my life easier on the TI calculator. On the TI calculator, TIs love these kinds of data, these kinds of frequency scores, right? So yeah, so the bin width for the first one's 10. The bin width for this one is 1. We're actually counting by ones here, right? Because the scores are 65, 66, 67. So let me make that bigger. So again, on the first example, if you're using your TI calculator, your bin width is 10, and then it automatically left justifies. So again, that's that question. Well, if it's counting in groups of 10, what does it do with 70? It puts it with the 70s. What does it do with 80? It puts it with the 80s. How do I know that? Because that's the way these calculators work. Left justification is kind of, or left alignment is its default setting. I don't think you're allowed to change that on these things. But for the apps, you have to tell it that. Desmos needed to be told that, where's Desmos? Where did I put Desmos? Desmos needed to be told that it's aligned left. The other app needed to be told, this guy, needed to be told that it's lower class limits that are the boundary. So that would put the 70 with the 70s, and the 80 with the 80s, and the 90 with the 90s, etc. Okay, so for the second example, it's already in a frequency table. So on the TI calculator, you just put this in L1, you put this in L2, and it makes the histogram much, much better. This one looks kind of like it might be a normal distribution. It looks much more like a normal distribution than that one. Follow the cursor. That is looking more like a normal curve. It's not perfect, but it's a lot closer than the last one. So I'd be looking at this one and saying, maybe yes, graphically. Let's prove it algebraically. So again, the algebra tells me when I run this through my calculator that the mean is 72.25, the standard deviation is 3.15. Now, I actually took the time to try this on Desmos. Desmos, this is the big problem with Desmos. Desmos doesn't know how to deal with a frequency table. So I actually took the time. Now again, I kind of used Word and made a shortcut and just kind of repeatedly cut and paste the same numbers. And then I typed them in to Desmos in Unit B. So let me turn off this histogram here. So I put them into B. And what I did was on the table where it says that 65 happened once, on Desmos, I typed 165. When it said that the number 66 happened twice, I typed in 2 66s. You see where this is going? When I got to 72, I had to type the number 72 12 times. So I typed all 96 numbers. Now again, I kind of cheated. I kind of used a cut and paste and just went, tick, 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 like that over and over again. But it's still, so it took me a while, but I did it. I have put the numbers into Desmos. So this is kind of a drag, right? But I did it. And once again, I can now find the mean for this data. So Shift B. and I can find the standard deviation for this data. Shift B, and there we go. Same as the numbers that we got here. Now, this is results from a Masters golf tournament. We assume it's a population. It's not, doesn't say it's only some of the players, so that's why I use the population standard deviation. And that's the one that the calculator uses automatically. That's the sigma one, right, lowercase sigma. Okay, so that's how we get the numbers, and again, let's run through how that works algebraically. Algebraically, let's go to a page where we can do the algebra. Okay, so the standard deviation and the mean are these two numbers. So there's the mean, there's the standard deviation. Oops, didn't mean to do that. 3.15. Okay, so there's the two numbers. One standard deviation to the left would be take this number minus that number, which is 69.1. One standard deviation to the right is this plus this number, which is 75.4. I have to find out how many numbers are between there and there in this set of data. On the TI, that's not that hard. You can use the sort function. Okay? On Desmos, I think you can sort on Desmos too. Right? You can put them in order from smallest to biggest, but these ones are already smallest to biggest, so this one's kind of done for me already. So how many are between 69, not including 69, because 0.1 is past 69. So how many are from 70 to, and this is including 75. So how many numbers are between 70 and 75? So I go back to the data on Desmos and I just count. So let's see, so starting here, so from 70 to 75, and I just start counting, and I count here. Or maybe the easier way to do it would be to just go back to the original data, right? Go back to the worksheet. How many are between 70 and 75? So 8 plus 11 plus 12 plus 19 plus 5. If you add those numbers together, so again, let me highlight them for you here a bit. So how many are between 70 and 75 inclusive? 8 plus 11 plus 12 plus 19 plus 5 plus 9. Add those numbers together, and you get 64 numbers. It said in the question that there was 96 players. So what is 64 out of 96? How many people is that? Look at how close this one is. That's exactly 2/3. So how close are we to our magical 68%? Close enough. I would say this is very close to being normally distributed. So that's how I do that one. If I was using an online app instead of Desmos, other than Desmos, again, I can use this guy, right? Frequency table calculator. I just have to enter 65, 66, 67, and then on the bottom row, put an F and then a colon, 12286. And this one would do the same calculation for the mean and standard deviation. This one, of course, though, doesn't graph a graph. You'd have to go back to this guy for that. But it would be pretty easy for this one because it's already in a frequency table, right? The frequency table, the lower limit is 65. The class width is 1 this time. The number of classes is 65 to 80, which is 1, 2, 3, 4, 5, 6, 7, 8, so it's 16. So 16 classes. And prepare the table, and then there we go. How many 65s are there? 66s, 67s, 68s, 69s. So you just have to put the numbers in. So it's 12286, 12286, and then you just keep going until you've finished it, and it'll draw the same chart for you that Desmos does. When it's already in the frequency table, this is a super easy app, and the TI does it really easily too. Okay, so I'm actually going to stop this video here, so if there's people who just wanted to see me go through this stuff, they can just watch this part of the video, and then I'll start a new video for today's lesson, because we are going to do a new lesson starting right now. Okay, so thanks for watching this one on the 5.4 assignments.